cross product. Now, cross product, cross. All of you know how is a cross like, right? Of course, this is also a cross. But then in cross product, we are using that multiplication type of cross. Okay? Right. The cross product is also known as a vector product because of the fact that the product turns out to be a vector quantity. So we assume let A and B be two vectors, then A cross B is denoted by magnitude of A multiplied to magnitude of B, and then a sine of theta. Okay? Sine of theta, where theta is the angle between A and B. Right? On the top of that, you have got certain n cap. That n cap will force this quantity to be a vector, because n cap is a unit vector. So up to here it is scalar quantity, but on multiplication with n cap is a unit vector perpendicular to both A and B. You will know, suppose this is your A, right? A, and that's your B, right? And theta is the angle between them. Then that n cap is a unit vector perpendicular to both A and B. So that is the reason, you know, when we take the cross product of A and B, it will create a new vector perpendicular to both. That means A cross B will be a vector perpendicular to both A and B. So this is to be noted properly. A cross B will be a new vector perpendicular to the plane containing A and B. So it will be like that, right? Where n is a unit vector perpendicular to A as well as B. So since, okay, where you can introduce your theta also. Theta is the angle between, I'll make it short, angle between A and B, and n cap, yeah, n cap is a unit vector perpendicular to both A and B, right? Okay, I'm going to use a blue one. Let's see it will work out or not. A and B. So what happens? Theta is what? Theta is a unit. Theta is the angle between A and B, and n cap is a unit vector. Yeah, unit vector perpendicular to both A and B. That's right. Okay, that's done. So that is the reason. You see, note that A cross B is not equal to B cross A. You know what happens? B cross A will be a vector opposite in direction to A cross B. This will be your B cross A, right? So they are not equal. Of course, they are equal in magnitude, but not in the direction. They are directly opposite to each other. So, you know what happens. As you know that you have got the preliminary knowledge about vector. If it is vector x, and if there is a vector directly opposite to x and equal in length, then it will be denoted by x minus. Owing to the fact that the magnitude is same, the length is same, but the directions are opposite, directly opposite. So we note that A cross B is not equal to B cross A, but A cross B can be equal to minus B cross A. This is to be noted down. Okay, right. Now, what do? You have that one. Then also A cross B can be expressed as A cross B is equal to I cap, J cap, K cap in the determinant form. Okay, in the determinant form, you have done a lot of determinant, we have done it already. So A dot B is I, J, K in the first row, and then suppose A is A1I plus A2J plus A3K, and B is B1I, okay, plus B2J plus B3K. We'll try to express A and B that way. So you pick up the coefficient of IJK, so and put it there in the second row. That will be A1, A2, A3, and B1, B2, B3. B1, B2, B3. And then you can work it out. You can just try to find out the value of the determinant, and that will give you the value of A cross B. Okay, right. If you interchange the rows, what will happen? The sign of the determinant will change. So also the sign of this will change. That means A cross B will be equal to B cross A. That will be minus B cross A. Okay, right on. Now, what about the angle? How to find out the angle? This one, right? Sine of theta, as you know that we know, let us call it 1, okay? 1 from 1. Okay. Now A cross B was magnitude of A multiplied to magnitude of B, sine of theta, and n cap. So I am denoting this one without the bar. So A, B, these are the magnitude of A and B, sine of theta. So up to here it is a scalar quantity. So scalar quantity will just remain as it is. So it will be A, B, sine theta, right? And then magnitude of n, since it is a unit vector, yeah, this n is a unit vector, so the magnitude of n turns out to be 1, so multiplied to 1, that turns out to be A, B, sine of theta, right? So note down that therefore sine theta will be equal to modulus of A cross B divided by AB. So this is what you are going to do when you try to find out the value of sine theta when two vectors are given to you. And similarly, you remember your dot product, don't you? Dot product. Dot product helps you to give the value of cosine theta in between the two vectors. That is, cos theta will be equal to A dot B divided by AB, simply. So they look similar. But here, mind you, the modular sign is there. That means you are going to find out the magnitude of A cross B, right? Okay. So we will try to work out this problem now. Last problem, okay? Right. Okay, now we are going to try to solve this problem. The problem says find the unit vector perpendicular to each of the vectors 1, minus 1, 2 and 2, minus 3, 1, and find also the angle between, sine of the angle between the two vectors. Okay. Now before I go for this, let me try to say what does 2, 3, 4 means. 2, 3, say minus 4. If it is given in a vector problem, it means what? It means 2i plus 3j minus 4k. I hope I am clear to you. So you need not be doubtful or you need not be puzzled when you see this kind of expression, that is the expression in coordinates, right? In coordinates of three-dimensional geometry. So 1 minus 1, 2 will be what? It will be I minus j plus 2k, right? And what about 2 minus 3, 1? It will be 2i minus 3j plus k, right? I hope it is clear. And vice versa. That means this one could be written like this and this one could also be written like this according to your need, right? Okay. Now you got to find out the unit vector perpendicular to both the vectors, that one, right? We have the vectors. Okay. Vectors, say A, shall we? A be equal to 1 minus 1, 2, right? That is equal to, what is that? I minus j plus 2k, say, suppose, because this is our supposition, and B equal to the other vectors, that is 2 minus 3 and 1. So that gives you 2i minus 3j plus k, right? So therefore, you got to find out A cross B. A cross B, as we have already seen, it can be written as I, J, K on the top, right? Mind you, this particular sum was said so many times in the year 12, 13, 14 and 15, serially. Okay, well, that is a different thing altogether. A cross B, so how are you going to write? A appears first, so you take the coefficient of ijk of A. So it is 1 minus 1, 2, like it appears there. 1 minus 1, 2. And in the third row, it is followed by 2 minus 3 and 1. Now let's try to calculate it. I, alright, you delete the row and delete the column, right? So you are left with this vector minus 1 into 1, diagonal wise. Minus 1 into 1 gives you minus 1. Subtract minus 3 into 2. Minus 3 into 2 gives you minus 6. So when you are subtracting, it gives you plus 6, right? So plus I followed by minus j. So you delete the row and column containing j. So you are left with what? 1, 2, 2, 1. So 1 ones are 1 into 1 is 1. Subtract 2 twos are 4. Well, it doesn't become plus because 2 2s are 4 is a positive quantity, so we have to subtract that. And lastly, plus k, that is plus minus followed by plus k. Delete the row and delete the column containing k. So 1 into minus 3 is minus 3. Subtract 2 into minus 1 is minus 2. Subtracting minus 2, you get a plus 2. Right? That's complete. Okay. That is, will be what? 6 minus 1 is a 5. 5i. 5i. Minus, this is 1 minus 4 is minus 3. Minus 3 multiplied to minus will be plus 3j. Right? And 2 minus 3 is minus 1. So it's going to be minus k. Is it okay? So what have you seen? A cross B turns out to be 5i minus 3j minus k. It itself is a vector quantity. Right? Okay. What about this one? Mode of A cross B. Mode of A cross B is, like we have already learned, that is the magnitude of A cross B will be square root of the sum of the squares of the coefficient of I, j, k. So it will be 5 square plus 3 square plus minus 1 square. Is that right? Right. So this is 25, 25 and 9. 34, 34 and 1 is it 35? Check. 1 and 9, 10. 10 and 25 is 35. Right? So that is that. So therefore, what is unit vector? You recall, unit vector along a vector A is given by what? Vector A divided by magnitude of A. So similarly, the unit vector along A cross B is given by A cross B, right? A cross B divided by mode of A cross B, that is magnitude of A cross B. So therefore, the unit vector along A and B is given by, what is that? A cross B, that is, of course, it will be a vector divided by mode of A cross B. Now you have this one already, that is equal to 5i plus 3j minus k divided by how much? Root of 35, right? So your answer is ready. The first part of your answer is ready. So therefore the required vector, I'll put it short, required unit vector is equal to what? Is equal to 1 upon root 35, right? And then 5i plus 3j minus k. Right? Okay. What about the sine of the angle between them? You know the result. What is sine theta? Sine theta also. And also, if theta is the angle between A and B, and B, then what is that? Sine theta will be equal to what? It will be mode of A cross B, that's right, upon A and B. A and B. Is that right? Do you know the value of A cross B? Mode, it is already root 35. But this has not been calculated, right? So that you can calculate easily. Will you? What will be mod of A? Mod of A will be square root of the sum of the squares of the coefficient of ijk. What are the coefficient of ijk? That is 1 minus 1, 2. 1 square plus minus 1 square plus 2 square. That's it. What about B? Mod of B will be 2 square plus minus 3 square plus 1 square. Okay, get it done. That will be root 35. Then this will give you what? 4, 5, 6, root 6. And then this will give us what? 9, 4, 13 and 1, 14. Right? Are you able to cancel some of them? Answer is very much yes, because this will be root 7 into root 3. Is it okay? Then root 6 can be written as root 3 into root 2. And this one can be written as root 7 into, what is that? Root 2. Fine? Okay. So this is okay. If you are getting confused, you can put the multiplication sign. Root 3 gets cancelled with this. 7 gets cancelled with this. So how much you are getting? You are getting 1 upon root 2 into 2 is simply 1 upon 2. Now since you want to find out sine of the angle between them, sine of theta is equal to half. If you want to find the angle between them, then what will be the answer? Sine theta is equal to half. Then theta must be how much? For what value of oh yeah, I'm sorry, there is something wrong here. Tell me. Yeah, 7 into 5. That's right, yeah. To err is human, no? And to rectify, divine. So that's it. Root 7 into root 5 is root 35. That's right. And this is root 3 into 2 and 7 into 2, that's right, that's 2. So it turns out to be root 5. Is that right? So no cancellation here. And then, of course, please bear with me. This is the root 5, so it is not cancelling with this. So it is going to be 2 root 3. Is it okay? So it could also be written as half of root over 5 upon 3. Check once again. This is root 35. So 7 into 5, 35. So 3 into 2 and 7 into 2. That's right. Then 7 is cancelled. This is still alive. Root 2 into root 2 is 2. Root 3 remains that one. So root 5 upon root 3 can be written like this. So therefore sine of theta is half of square root of that. All right. Yeah, I was making that mistake, you know, and Sir Jeff has rectified it. Thank you, Sir Jeff. Therefore, sine theta turns out to be how much? Half of root 5 upon 3. So that's the answer of this question. So in the next meeting, we shall be doing some more of this one, or something else we'll be doing, but then we'll be doing some problem, of course. So till then, you take care of yourself and have a good day. Thank you very much.